So thank you for joining today's session. And before I get started in building a small university network, okay, let's have a quick recap on what Inter-VLAN routing, how it works. So in yesterday's scenario, when a student from one class wants to talk to the student from another class, it is a kind of a inter-class communication. Okay, within the class, a student and another student both belongs to the same class. The teacher of the class will take care of the communication. In our networking terminology, when you wanted to communicate from one VLAN, VLAN 10 to VLAN 10, the switch itself will take care of the communication. Now, if you want VLAN 10, a student from one class, and talks to the student from another class, VLAN 20, switch will not be able to handle this communication. This communication is called as inter-VLAN communication. So you need a special person called principal office, where you go to principal office and he knows where that student belongs to, and he'll be sending the traffic to that particular classroom. Okay, so the analogy principal office is nothing but a router. The router is a layer 3 protocol, layer 3 device, which works in IP addressing. Switch is a layer 2 device, which works on MAC addressing. Okay, so to achieve this inter-VLAN communication, what we did yesterday. So this is your HRPC. It is in VLAN 10, 192.168.10.10, and Finance PC 192.168.20.10, and it is the ITPC 192.168.30.10. So all these three PCs having three different VLANs. So this is kind of an inter-VLAN communication. So you are adding a router. So initially you will configure this fast Ethernet 0/1, this port 0/2, this port 0/3. In access port mode access, and you'll be configuring the access VLAN respectively 10, 20, 30. And from switch to router, it has to carry all the three VLANs. So you're going to configure this port as trunk mode. Trunk mode means which allows multiple VLAN. Access port means which allows single VLAN. So now what we're going to do on the router, can I call this router as a router on a stick? It is sitting on one single cable. Okay, so basically this terminology is called as a router on a stick. So in a physical interface, you can assign only one IP address. But in our requirement, you need to handle the traffic from all the three VLANs. So which means you need to create a three sub interface. Fast Ethernet 0/0 is the physical interface. Fast Ethernet 0/0.10 is going to be the sub interface for VLAN 10, and sub interface for VLAN 20, and sub interface for VLAN 30. So you're going to configure encapsulation .1q 10, 20, 30 respectively. Okay, and every interface you create, you are going to configure one IP address. So this is in the 10.1, 20.1, 30.1. Okay, so from PC, this is your PC, 10.10 is your PC IP. You're going to say your your gateway for the PC is this interface, the router interface. So that's the reason we have given 192.168.10.1. Finance PC, we are going to say to Finance PC that I'm the gateway for your communication. So you will be configuring 192.168.20.1. So similarly, IT-PC also will be configuring. So after this, you can achieve the inter-VLAN communication. So HR wants to talk to Finance PC. It goes to the switch. Switch will forward to all the ports. It broadcasts to all. It forwards the frame. It broadcasts the frame to all the ports, and this router logical interface will receive the port. Okay, will receive the packet, and router knows where VLAN 20 is connected, so it will forward to the 0/0.20 interface, and from there these guys will reach to the Finance PC. Okay, so this is the Inter-VLAN routing. This is how in a single topology you have your switching, also your routing works. You are learning the MAC address, you are forwarding the packet using IP address. Okay, so let's, in yesterday's example, we have built a similar exercise. We created the local area network, and we have created two PCs from two different VLAN, VLAN 100, VLAN 200. And if you go to the switch, and if you see show MAC address table, you know very well, switch learns MAC address. It stores MAC address. So it says my router interface is 0/4. So already I've learned the logical interface which is connected to 0/4, and its VLAN is 100. Similarly, the router's interface, the logical interface 0/4, and the VLAN is 200. So whenever a PC receives a ping from VLAN 100, switch will forward to all the ports which are part of VLAN 100. So it goes to the router, and router will do the routing, and it comes to the switch, and it goes to the 200 VLAN. So this is how the communication takes place. And if you go to the router, you ask the router, what is your route? Whenever you receive a packet, what you do? Show IP route. So it says, I have two subnets, and this interface is locally connected, handling the 100 VLAN, and this interface is connected, handling 200 VLAN. So initially the packet receives here, and it knows for 200 VLAN, it has to forward to this 200.1. Okay, and that's how the communication takes place. Fine. Now let's clear this. I wanted to build a simple university network. Okay, so what is your requirement? So you need to handle this mini assignments in three ways. One is physically planning your network. Okay, so that includes your IP planning, VLAN planning, Let me enlarge this. Oops, I closed it. Okay, so we are going to do this 3 tasks to build this university network. So requirement is you'll be having a main campus and you'll be having a remote campus, which is far. Main campus will be the main building, which is having multiple buildings. So main campus will have 3 buildings. So building 1 will be the staff people, and building 2. Okay, so building 1 will be the main building where admin, HR, and IT people sits. Building 2 where staff, teaching staff and non-teaching staff stays. And there is a third building called, it's a student labs, and also some kind of servers, university application is hosted. Say like attendance application, some kind of financial application. Okay. So main campus, it has 3 buildings. In that, first building have first floor admin people are sitting, second floor HR people are sitting, and third floor IT people are sitting. And building 2, you have staff and non-teaching staff. And building 3, you have student labs where multiple students are working on the labs. You will also have a lot of servers, a lot of equipments, and you're going to have a university application hosted application devices. Okay, so this is the main campus. Now, remote campus. So say like your main campus is located in the center of Bangalore. Okay, you have a very big campus, building 1, building 2, building 3, and the remote campus, it is somewhere located, some outskirts of Bangalore, okay, which is like 50, 60 kilometers away. So that people can come, it's a small campus. Okay, it's a very small campus with limited teaching staff, with limited students can be accommodated. So it has only 1 building. Okay? So where staff and students, okay, and you are going to have a cloud. Say for example, everybody will have the email IDs, your mailbox, Outlook you're using, right? Similarly, you're going to have an email server on the cloud. Okay. Excuse me. Now, requirement is build a university network with main campus, remote campus. Ensure all are interconnected. Okay. And second, main campus and remote campus can communicate the email servers host in the cloud. Okay, so requirement is very simple. You are going to build a university network, college university network. It has two main campus and remote campus, and all the staff, all the students can able to communicate with each other. Okay, so second requirement, main campus and remote campus can communicate to the email servers in the cloud. Okay, so main campus comprised of building 1, building 2, building 3, and remote campus, it has only one building, staff, student, are there. And there is an email server on the cloud. We need to configure that also. So we need to plan this in three ways. First is physically planning your network. Okay. Second one is configuration. Third one is verification. Okay. So first one, you're going to plan your network, how your network devices, what network devices you need to achieve this requirement. Second one is, okay, I've put all the network equipments. Now I'm going to configure it. Okay, I'm going to configure it. Configure the devices so that my task is achieved. And third point is verification. Okay, I've configured something. Did it really work? Did I achieve the task? Okay, so this is what verification we are going to do it. So let's go one by one. Listen to this carefully. In this single exercise, you will be able to understand VLAN completely. You'll be able to understand the goodness of DHCP protocol. Okay, and you'll be able to understand basics of routing, and you'll understand how switch works. Okay. Yeah. So these are all the technical aspects where you will be getting really confident after completing this task. So let's start building. First one is physically planning your network. Okay. So that includes your IP planning, VLAN planning. Let's get started. So I'm going to have a main campus, which is okay, don't fill it. And can I make this as a main campus? Okay. And I'm going to create a remote campus. I've created main campus and one remote campus. Okay. And here we have one more requirement of having the email server on the cloud. Let me take some other color, and I have email servers. It's not that visible. Okay. So I've created main campus email servers. Okay. So right now we are in the phase of physically mapping our requirement. So we have created main campus, we have created some on the cloud email servers, and we have created a layout for remote campus. Good. So far, so good. Now, in main campus, there are 3 buildings. So we have 3 buildings. So this is your building 1. This is your building 2. And this is your building 3. Building 1, building 2, and building 3. Okay. And so in building 1, let's go to the requirement. In building 1, 3 people are there. 3 sets of people are there: admin, HR, and IT. So admin sits in the first floor, HR sits in the second floor, and IT sits in the third floor. Example. Okay. Now I'm going to make a floor-wise connection. Say like so admin sits in the first floor, and the second guy sits in the second floor, and the IT person sits in the third floor. Okay. So let's map this. You can say admin. Here you can mention HR. You can mention IT. Okay. Now let's create a network device. Let's create a switch 2960. Created one switch to HR, one switch to admin, and one switch to IT. So building 2 hosts its staff and non-teaching staff. So let's say only staff is available. Okay, to cut short the. So we have staff. So I'm going to have one switch. So if you carefully look at our structure, as discussed, we are going to build a data center kind of a architecture. It's a 3-layer architecture where core layer connects to the router, aggregation layer, it aggregates all the downlink devices, and the third layer is called as access layer. Access layer is nothing but where it connects to the end devices. So what we are working is the access layer. So we have created building admin 1, we have created HR, IT, okay. So building 3 will create the students, and so far so good. Okay. Now let's create an aggregated device. So I'm going to go to the switch. I'm going to say one switch 3560. This is I'm going to use this as an aggregator. Okay. And so this is your understanding aggregator. Okay, fine. Now listen to this carefully. We have done the physical planning. So main campus, you will have one aggregator, and every building will have the switches respectively. And to connect all these things, we need a special device called a router. Okay. And I'm going to say this is my main router or main campus router. Okay. And remote campus, I'm going to similar structure. So one for staff and one for students. And I'm going to have a aggregator here. And I'm going to have a simple router there. Okay. So just wanted to differentiate. I'm going to mention this as a staff. And I'm going to, this is a student network. Okay, fine. Can I connect the end device now quickly? Say, for example, I'm going to connect PCs. I've connected the PC. And if you want, you can connect some printers. Okay, so you can, no space is there. So I'm connecting here. So I'm going to connect end device in each floor. There could be one PC, there could be 100 PC connecting to the ports of the switch, subject to the ports availability in the switch. So let's connect the switch. Now, end device. We also call this an host. This is staff. This is for student and email server. Can I connect some email server? And I'm going to connect some router in the cloud. Say like cloud router. Okay. Now, this part is done. Physically placing the devices is done. Now comes to the VLAN assignment. So what will be the VLAN for each device, VLAN and IP? Let's do that. So I'm going to mention this guy as VLAN 10 and his IP address would be 10.192.168.10, which is represents the VLAN, and 0. So anything connecting, any devices connecting this building will get IP address in this range. Okay. So I created, this is an admin block, an HR block, this is an IT block. So let's check. For this, I'm going to have VLAN 20 and IP will be 192.168.20.0 subnet mask. Similarly, this guy will have VLAN 30 and he will have 192.168.30.0. Okay. So this guy will have VLAN 40 and IP will be 192.168.40.0. This guy will be VLAN 50 and IP will be 192.168.50.0. This is the label, nothing to do with the configuration. And let's create for this staff also in the remote campus. This guy will have VLAN 60 and IP will be range of 192.168.60.0. So the student guys will have the VLAN 70 and IP will be 192.168.70.0. Okay. Now, so far so good. Okay. I'm going to do the connection. So if you know the devices, switch and PC, it's a different type. So you're going to connect straight through cable. If it is of same type, like PC to PC, it is going to be the crossover cable. So to make it easier, I'm going to select this automatically connection type. Going to connect, going to connect. So we are done with IP planning, we are done with VLAN planning, and we are done with the connection in the access layer. If you see, all the ports are orange color. The reason is switch is very cautious. It will check who is connecting to the switch. It will check, it will validate for some time. This process is called as port fast. It takes 30 to 50 seconds for this switch link to be fully operational. Okay, so that's the reason you have seen orange color and now it is green color. Okay, so now let's have this connection also. So this is an aggregator. What it does, instead of you are connecting all these things to the switch, you are aggregating, you are collecting all the links and you are connecting to this router. So we'll do that communication. Connect. Connect. You see the orange color? The port fast scanning what the ports are connected. If it is okay, then it will be in the green color. So I've connected this link. Similarly, we'll connect the remote campus. Okay. And also we are going to connect the router link. From switch, aggregator switch to the router, from aggregator switch to the router. So if you see, initially it was orange color and now it is slowly turning up to the green color. The ports are fully active. Orange means the port, the link is not operational. If you see, the connection in the router is always red. I've discussed router's interface default, it is shut mode. You need to physically go to the router's interface and make the port as unshut. Similarly to this, okay? Now, can I configure the access layer now with this VLAN configuration? So this is going to be the VLAN 10, this is going to be the VLAN 20, this is going to be the VLAN 30, etc., etc. Okay, so let's connect this also. Okay, so our physical planning is done. Main campus, building 1, admin, HR, IT, or on different floors. Admin, HR, IT, all are in different floors. They are connected to their end device, which is also called as host. And building 2, it is connecting to the staff. And building 3, it is connecting to the student labs. And also, you will have some kind of a servers where the university applications are hosted. Okay, so far so good. So we are done with access layer. We are done with aggregator layer. So this layer where routers are there, it's called as core layer. The aggregator layer, we call it as a aggregator layer, where the aggregator switch is present, and all the access switch. These are all called as access switch. Okay, where the end devices are accessible. So these are all called as when you're working in a real work environment, right? You would be communicating with your language. Your work language would be like, is some issue with the access switch, some issue with the aggregator switch, some issue with the core router switch, core router. So this is how you guys speak, in the course of your work. Okay, so far so good. Let's go to the switch, and switch has 24 ports. This is all 24 ports. You go to the CLI mode, and I'm going to mention conf t. If anything, you wanted to do it on the if you wanted to talk to the switch configuration terminal, and you're going to mention okay, list down all the interface. Do show IP interface brief. It is 24 port fast Ethernet. So fast Ethernet means it is 100 Mbps. Okay. So now what I'm going to do, interface fast Ethernet 0/1. I don't have time to configure each interface. So I'm going to configure in the range fast Ethernet 0/1 to 0/24, and I'm going to say them, you all guys are belonging to access. See, as of now, admin person, one PC is connected. There may be conference room, there may be meetings room. So where somebody may join tomorrow. So whenever they connect the laptop in the conference room, when they connect some network device in their meeting room, they will get the IP. They'll be part of the network, because in the background, I'm doing something like this. All the switch in this floor, I'm going to make the switch port as access. I'm going to configure the switch port access VLAN as 10. What it says, there is no VLAN, but I'm creating VLAN for you. Okay, let's verify. Show VLAN brief. So it says 10 VLAN, and all your fast Ethernet port from 1 to 24 is part of this VLAN. These people are the members associated with this VLAN 10. Okay, cool. Now the configuration is done. Similarly, go to this CLI enable conf t, and I'm going to say so for interface fast interface range fast Ethernet 0/1 to 24, switch port mode access, switch port access VLAN as 20. Okay, done. Go to the third device. Conf t interface range fast Ethernet 0/1 to 24. I'm going to configure you guys as VLAN 30. Okay, done. Building one is completely done. And this guy is VLAN 40. Let's check. Conf t interface range fast Ethernet 0/1 to 24. And I'm going to mention like switch port mode access, switch port access VLAN as 40. building, which is 50. So it says something like this: interface range fast Ethernet 0/1 to 24. Okay, let's check why it's showing like this. Do show IP interface brief. It says only a few interfaces only there. Why it is like that? Let's check. Physical, you see, right? It is only having 4 ports. 1, 2, 3, 4. Okay. Let me check whether I can add some ports. Okay, fine. So 4 ports are there. Let me live with this 4 ports, no problem. Fast Ethernet 0/1, 1/1, 2/1. So I'm going to say interface range fast Ethernet 0/1 to 2/1. Not allowing. Switch port mode access VLAN as. What is the VLAN in the switch building? It's 50. And I'm going to assign the same thing in the other interface. 1/1. I'm going to mention access port. I'm going to mention VLAN. Next 2/1. I'm going to mention mode access. I'm going to mention VLAN 50. Okay. So all the switches are in the same VLAN 50. So similarly, let's finish this VLAN 60. So let's check how many interfaces are there. Show IP interface brief. It has 24 ports. Okay. Interface range. Fast Ethernet 0/1, 24. Mode access. Switch port access VLAN as 60. And last building for student switch. Quantity. Interface range. Fast Ethernet is 1 to 24. Port mode access, switch port access VLAN 70. Okay, so I'm done the configuration for all the access devices, access switches. I have completed my configuration. So now listen to this carefully. I've configured access mode, which means it can carry one VLAN. This is carrying one VLAN. This will carry one VLAN. Okay. So now when it goes to the next device aggregator, you see each switch is connected to one interface, which means I can configure this port also as an access because it's going to travel only one VLAN. See, in the same switch, if you are going to configure multiple VLANs, this link you need to configure as a trunk. Now, the entire switch I configured one VLAN. This switch I configured one VLAN. This switch I configured one VLAN. So I'm going to make this interface as access mode to carry VLAN 10, to carry VLAN 20. Okay. So let's check. Okay. Cool. So what is this interface? This is fast Ethernet 0/1. Log into this aggregator device and just say no, and you configure interface fastness 0/1. You mention it is an access mode because I'm going to carry only one VLAN in this link. Mode access, switch port, access VLAN as 10. Okay. So this is done. Similarly, I'm going to configure for VLAN interface fast Ethernet 0/2, switch port mode access, switch port access VLAN 20. Third interface fast Ethernet 0/3, this switch port access VLAN 30. Similarly, go to the next interface 4 and oh, I'm sorry, it should be 40. Okay. Now 4 is done. 1, 2, 3, 4 is done. Fifth interport, it has to be VLAN 50. Let's configure that. Fifth interface and VLAN 50. So I'm done with aggregator switch configuration. How about this one? This is an only one link connecting to the router. It has to carry all the VLANs, multiple VLANs. So you're going to configure this link as a trunk mode. What is this interface? 0/6. So I'm going to say interface faster than 0/6. I'm going to say your mode is trunk and command rejected. An interface whose trunk encapsulation auto can be configured. Okay, fine. So you mentioned this to this interface. Your switch port is going to be trunk and you're going to have an encapsulation as .1Q. Now we're going to mention your mode is going to be trunk mode. Show interface IP interface brief. It will show all the interfaces what you configured, whatever it's connected. Okay, so the configuration on the aggregator layer is done. So let's go here. Let's complete this communication also. 0/1 has to be in the VLAN 60 and 0/2 it has to be VLAN 70. And this interface 0/3 has to be the trunk. Get into the CLI mode for the remote conf t interface fast Ethernet 0/3, which is the router interface connecting to the router. You mention your trunk, your encapsulation is .1Q, and you mention like your mode is trunk. And going to the staff connecting access switch interface fast Ethernet 0/1. Mention your switch port mode is access, and you are going to carry VLAN 60. Similarly, go to your interface connecting to the student switch and make it as access again, and VLAN is 70. Okay. So far what we did, we have configured this access switches in the VLAN 10, VLAN 20 as an access port, and also the aggregator devices connecting to the downlink devices. These are all called as downlink devices or called as access layer. So all this interface is also configured as an access mode. Okay, so this interface is configured as what it's configured as. So it's configured as trunk, and this is configured as a trunk again. Okay, so our configuration in aggregator layer is done. Our configuration in access layer is done. Okay, now very important. In the start of the session, I recapped about Inter-VLAN routing. Okay, so this part is done. So router will have one interface, but we need to create each logical interface for one VLAN and assign an IP address in that logical devices. Okay, so let's check. Go to the router, CLI, no. So before I start, let me finish the connection between main campus and remote campus. So let me power it on. And I'm going to connect from year to year. And I'm going to connect from year to year. A cable cannot be connected to the port because if you see this, the router, okay, device has to power on. So this is loading. Every router interface has to have an IP address. Show IP interface brief to check how many interfaces are connected. You see router interfaces are default, it's down. So you just go to conf interface gigabit 0/0/0 and do no shut. The port will be up. Similarly, go to this interface 0/0/1, do no shut. Similarly, go to interface 0/3, do no shut. Why it is not invalid input? Let's check. Interface 0/3. There is no 0/0/3. It is 000, 001, and 002. No shut. Now show IP interface brief. All ports are up. All physical ports are up. Now listen. This port came up. Now this is gigabit 0/0/0. Let's go and create a virtual interface, or also called a sub interface, for each VLAN. Okay, so remember this. Your VLAN subnet is 192.168.10.0. Second one is 20.0. Third one is 30.0. Okay, let's go to the CLI and conf t interface gigabit 0/0/0 dot, this is for VLAN 10, and I'm going to say your encapsulation is .1q handling the VLAN, and your IP address will be 192.168.10 VLAN, and your IP address is going to be 1.255.255.255.0. No shut. Let's get into the another interface. Interface gigabit 0/0/0.20. Okay. And you're going to mention your encapsulation is 20, and your IP address is going to be 20.1, which is VLAN 20 subnet. You see, VLAN 20 has 20.0. So in that, I'm going to assign 20.1 in the for this gateway. Exit. Similarly, assign for 30. 30. I'm creating multiple sub interface. Now I'm going to say VLAN for 30, and I'm going to say IP address for T. Okay, so building 1 is done. Building 2 is 40. Exit. Create 40. Sorry, create sub interface 40 and create 40 encapsulation and create IP addresses 40. Okay. Next one, create 50 VLAN subinterface and make the encapsulation .1q for 50. Make the IP addressing for 50. So as of now, let me complete with main campus. If time permits, tomorrow we'll see the remote campus connectivity. So as of now, the configurations are done. Okay. If you check your configuration, show IP interface brief. Initially, you had only 3 interface 0/1, 0/2, 0/3. Now you have created sub interface for VLAN 1, sub interface for VLAN 2, sub interface for VLAN 3, sub for VLAN 4, sub interface for VLAN 5. Which is 50, 40, 30, 20, and 10. Cool. Now, PC don't have the IP address still. You just go to the PC and IP config. It is no IP address is given because this many PCs are connected on the network, and I don't want to configure it manually. Okay, so what to do? I'm going to go for a protocol called DHCP, Dynamic Host Control Protocol. So I'm going to dynamically assign IP address to all the hosts in the VLAN. How to do it? Okay, let's check. Okay, let's check like this. I'm not going for DHCP. I'm going to manually configure it. Okay, so I'm going to configure this as 192.168.10.10, and I'm going to say my gateway is my router logical interface 192.168.10.1. Cool. Now go here, IP config. You have 10.10 is the PC IP, 10.1 is the gateway which goes to the router. Similarly, go here, configure So this is the VLAN 20, 192.168.20.10. And you mention my gateway is 192.168.20.1, which is the router interface, logical sub interface created. Close. Now, ping 192. Okay, let me ping my address. IP config. What is my address? 192.168.10.10. Ping 192.168.10.10. I'm able to talk to me. So that's okay. Now I'm good. Whether I wanted to check whether I'm able to reach from this PC to this router logical interface, which is the gateway. Ping 192.168.10.1. Yes, I'm able to talk to the router's logical interface. Okay. I'm able to reach here. Now I wanted to reach from here to here, which is different VLAN. Go to the switch again. Ping 192.168.20, which is the different VLAN, and IP address of the PC is 10. As requested, you see, right? The communication is achieved. This is the Inter-VLAN communication. Okay. Now go to here and go to that next PC, and now ping to this different VLAN. So what is my IP address? IP config is 10.20.10. Okay. Now I'm going to ping the other VLAN, 10 network VLAN. 168.10.10. This is the VLAN 10 PC. You are seamlessly able to communicate. It goes to here, it goes to there, and it routes the traffic here. Okay. Now go to the router interface. Now check show IP route. If you see, each VLAN will have logical interface, and this is the routing database. Okay. So router, whenever a packet receives on the router, it checks the routing information and it forwards. So I'll teach you this later. As of now, let's not worry about it. Now I'm able to communicate ear to ear, ear to ear. Okay. Now I'm not interested to configure each PC in my network. So I'm just changing, deleting everything. I'm changing, deleting everything. Now what I'm going to say, let me create a DHCP configuration so that my router only will handle or assign the IP to the PC. So configure terminal. Service I'm going to use is DHCP. Okay. What is the DHCP? DHCP, it assigns IP address dynamically to the PC. So I'm going to say IP pool, IP DHCP pool. I'm going to make this is for admin block. Okay, so for IP admin block, I'm going to create. So the network for admin block is 192.168.10.0.255.255.255.250. Okay, and anybody getting this IP address from this pool, I should be your gateway, which means default router, default gateway is my sub interface IP 10.1. If you want to talk to internet, again, you should talk to me first. If you type google.com, I will be giving you the IP address. So your DNS also, it's going to be me. 192.168.10.1. Everything I'm configuring in the router only. Listen to this carefully. And I configured a lot of things. So I wanted to save the configuration. So I'm going to give do write memory. Okay. Or do write. So configuration is saved. Okay. Now I configured this DHCP part. Go to the PC. Go to the IP configuration. There is no IP here. If you want, you can check. IP config. IP is 000, literally 0. Now go to the PC and request for IP address. So what it means, DHCP request is successful. I got a new IP address for my PC as 10.2, which is in this same network, 10.0 network. And default gateway is my router IP address. My DNS server is my DNS server is my again the router IP address. Okay, everything router sends. I mean the DHCP server sends to this host. Now any PC you connected to this building, they will get an IP address dynamically. Okay. Now let's check. So this is your building 2, right? Let's create one IP pool for building pool. Conf T, let's have quick. IP DHCP pool as building 2. And what is the network in building 2? It's 192.168.40.0. 192.168.40.0. And subnet mask could be 255.255.255.0. Okay. And your default router should be 192.168.40.1, which is my logical interface. And your DNS should be again, I should be your DNS gateway. And that's it. So I've written the configuration. I'm closing the router. Fine. So let's go to the PC. Open that and check for DHCP request. DHCP request is successful. You received an IP in 40 VLAN, 40 network, 40.2. If you see carefully, 40.1, it's not coming because it's already assigned to the router, logical interface. So 40.2, your default gateway is router gateway, your DNS is 40.1. Let's check here. Go to the printer, check for DHCP. You got it, right? You are getting some. So printer will not have its own IP address. Okay, it is just it's part of the network. It is part of the 40.1 network. So now I'm going to ping from 40 VLAN, which is 40.2. I'm going to ping to 10.2. Can I do that? Inter-VLAN ping 192.168.10.2. First packet will fail. Please do some homework. Why first packet is failing? And next packet, it will be successful. The clue for your homework is ARP protocol. Okay. Cool. Okay, so far what we have built the complete main campus network. Okay, so any PC from any building can communicate to any PC in the any building. So this main campus is done. So what we'll continue for tomorrow is we will have this similar configuration, and from this PC we are going to talk to this PC on the remote campus. For that, you need to enable a routing between this routers. Okay, so that will be more interesting, and I think tomorrow we'll continue this. As of now, we have learned. We have built the main campus and we have built the remote campus. Physically, we have done with our network. Configuration, we are done with access layer, aggregation layer, and core layer. And finally, as part of our verification, we are able to talk to any device in the main campus. So we tried both in DHCP protocol, and we also tried with static IP assignment.